When more than one event is taking place, the counting principle is used to determine the possible outcomes. The counting principle states that all the possible choices should be multiplied. For example, a student has 7 skirts and 6 blouses in her closet that she may combine to produce one outfit. How many ways can she combine all the skirts and all the blouses? The short answer would be 7 times 6 equals 42. In the long answer, consider that the first skirt will match with 6 blouses, and the second skirt will do the same, and the third one the same, and so on. 7 skirts matching 6 times each is 42. Another example. A printer has 16 colors and needs to select 2 of the colors for the cover of a book. One for the text, another one for the background. In how many different ways can the cover be printed? When the printer selects one color for background, there are 15 colors less for the text. If this is done for all 16 colors, each of the 16 colors with 15 other selections, then 16 times 15 equals 240 possibilities. Now to permutations. A permutation is when a set is rearranged. In other words, an event in which one thing is substituted for another. For example, in how many ways can the letters in the name Carlos be arranged? If you tried to do it manually by moving letters around, it would take a long time. However, the following equation can be used to solve it. Permutation equals n exclamation point, where n exclamation point is called n factorial. A factorial is the product of all the positive integers from a given number to 1. Because Carlos has 6 letters, the permutation is 6 times 5 times 4 times 3 times 2 times 1. The name Carlos can be rearranged in 720 ways. The next topic is combinations. Now, if order in selection is important, then permutation is the way to solve a problem. But if order is not important, then the equation for combinations can be used. The equation is combinations is equal to n times n minus 1 times n minus 2 times n minus 3, and so on. All of it over k factorial. By order, it is meant that selecting, for example, 3 students for a task, K, the order would be Mo, Pat, and Jerry, or Jerry, Mo, and Pat, or Pat, Jerry, and Mo. For example, in a group of 12 students, the teacher wants to make groups of 3 for a project. How many different groups of 3 could she make? The question here is how many combinations are there in 12 items taken 3 at a time? Applying the equation, n equals 12 and k equals 3. 12 times 11 times 10 equals 1,320. Divided by 3 factorial, which is 6, equals 220 different groups. Another example. In a group of 25 students, how many different groups of 6 could be made for a project? Again, apply the equation for combinations. N equals 25, k equals 6. Multiply down from 25 to 20, which is 6 numbers. 25 times 24 times 23 times 22 times 21 times 20. Divided by 6 factorial. The answer is 177,100 different groups.